Hello friends, how are you? Hope you guys are all well. Welcome to my YouTube channel. Today my topic is the science of the spring force. Okay, so science of a spring force in this video is explained is under explained topic. So many people are asking me to make the video on this topic, the science of the spring force. So the wait is over. Okay, so before moving to my topic, I will request you to please subscribe my YouTube channel and don't forget to watch my previous videos. Subject area: physics measurement, associated unit none, associated lesson none, activity title science of the spring force. Okay, summary is the students doing this activity are learning but one way of the measuring a distinct property of a simple complex machine, which involves the concept of the force and displacement as well as the use of the acquisition equipment in the engineering world. The material or the simple or systems are tested by applying forces on the material or system, and the measuring displacement that results. The relationship between the force applied on a material and its resulting displacement is a distinct property of material, which is measured in order to evaluate the material for a proper use in structures and machines. Engineering connections: the property that mechanical engineers study and measure is the spring or stiffness constant of a material, which involves the application of a Newton's law of motion, otherwise known as the Hooke's law. Various types of the test are conducted on different materials in order to determine the individual stiffness of each material. This is useful to determine the best type material for the design of the structure or machine. Engineering category number one relates science concept to engineering: force, displacement, spring, Lego, mindstorms, NXT, data acquisition, sensors, educational standards. Okay, New York Science 2010 PS5 LE PS 5.2 B. The Newton's third law: for every action there is always an equal and opposite reaction. Force as an interaction. Prerequisite knowledge: basic understanding of the force and simple complex machines and what they are useful for. Learning objectives: after this activity the student should be able to understand the Hooke's law and its application to springs, elastic structures. F is equal to kx. Understand the difference that a material makes in the design of a simple or a complex machine. Measure properties, collect data from testing of materials. Material list: a spring or a bungee cord, one next with an ultrasonic sensors, cardboard platform on the bottom end of the spring bungee cord, lab stand with attached clamp or rod parallel to the floor. Introduction or motivation: everybody machine like cars, computers are made up of many different parts, each with their own purpose, so that a machine can move and function properly. Many machines have a parts that need to move back and forth so that the machine can perform its function again and again. One of the parts used in the typically a machine is simple device we call a spring. A spring is an elastic device that comes back to its original position after it is pushed, pulled or bent. There are many examples of the springs in everyday uses, such as the right on the classroom board, rubber bands, bungee cords, small springs used in buttons found on computers, elevators, appliances, toys. Okay, so however, not all the springs are used for any type of the job or use, depending on the top of the material used as well as the size. The spring can be pushed to a different size or a shape. The machine or device that the spring is attached to may need to move a large distance or a small distance in the order to for a machine or device to work well. In order to predict how far a spring would compress or stretch, a relationship between the load applied and the displacement of the spring is given by the Hooke's law. Okay, so I think this is enough for today's topic. So time to go. Goodbye. Meet you in the next video.